One fighter jet costs as much as an entire city, and yet not a single country in the world can say for certain who would win in a fight between the Russian Su-57 and the American F-22. For 10 years, the West has insisted that the Russian aircraft is a failure, a cheap copy, a flying brick that can be seen on radar from hundreds of kilometers away. But what if all of this is nothing more than propaganda, and the real truth about the Su-57 is capable of overturning everything you knew about 21st century aerial warfare? To understand where this aircraft came from and why it became the most discussed fighter on the planet, one must go back to the 1980s, when a single word overturned the entire world of aviation, and that word is stealth. The Americans were the first to realize that the future of air combat belonged not to the one who flies faster, but to the one who is not seen. In 1988, at an airbase in Nevada, the B-2 Spirit bomber took to the sky, looking like a giant black stingray. It became clear that the rules of the game had changed forever. The Pentagon immediately launched the Advanced Tactical Fighter Program, with the goal of creating a machine capable of gaining air superiority before the enemy even realized the fight had begun. The result of this program was the F-22 Raptor, an aircraft spoken of as the pinnacle of engineering thought, an absolute weapon with no equals in the world. American generals did not hesitate to claim that a single Raptor could destroy an entire squadron of any fourth-generation fighters. And based on exercise results, it looked exactly like that. The Soviet Union, and then Russia, looked at this situation quite differently. Russian designers understood perfectly well that stealth is important, but they believed the Americans had become too obsessed with invisibility at the expense of flight characteristics. The logic was simple and Russian-style straightforward. What is the point of being invisible if you are detected from another direction, and you cannot dodge a missile because your plane maneuvers like an iron? That is why the Russian concept of a fifth-generation fighter was built on balance from the very start. Yes, reducing radar signature is necessary, but not at the cost of losing speed and maneuverability. In the early 90s, Russia launched the MFY program, the multifunctional frontline fighter. The Mikoyan Design Bureau presented its project, the MiG-1.44. It was an ambitious machine with a delta wing and canards, designed by engineers to compete with the Raptor. A prototype was even built and took flight in the year 2000, but by that point it was already too late. The 90s hit the country's entire defense industry with devastating force. Factories stood without orders. Engineers left to sell goods at markets. Program funding was cut to zero. The MiG-1.44 remained only a single prototype, and the MFI program was closed. But at that very moment, something surprising happened. While MiG suffered the wreckage of its hopes, the Sukhoi Design Bureau made a move that changed the entire history of Russian aviation. Using its own money, without a state order, without guarantees or contracts, Sukhoi began building an experimental aircraft to prove that the Russian engineering school was alive and capable of creating the technology of the future. This aircraft received the designation S-37 Berkut, and when it first appeared in public, the world gasped. The Berkut had forward-swept wings, a solution that no serial manufacturer in the world had dared to use before. The wings of this plane were pointed forward rather than backward, giving it a completely fantastic, almost alien appearance. The Berkut flew, maneuvered, and proved that the Sukhoi Bureau was capable of doing the impossible even in the hardest times for the country. It was the Berkut that convinced the Russian government that they should bet on Sukhoi. In the early 2000s, as the country's economy began to recover, Moscow launched a new program called PAK-FA, which stood for Prospective Aeronautical Complex of Frontline Aviation. There was effectively no competition between bureaus. After the failure of MiG and the brilliant demonstration of the Berkut, the choice was obvious. Sukhoi received the contract, and dozens of the country's best engineers sat down to design the aircraft that was to be Russia's answer to the F-22 Raptor. Work proceeded in conditions of the strictest secrecy. No photos, no leaks, not even approximate descriptions. The whole world wondered exactly what the Russians were building, and military forums and blogs were overwhelmed with rumors and speculation. No one knew what this classified fighter looked like, but everyone understood one thing. When it finally revealed itself, world aviation would never be the same. 10 years of secrecy ended on a freezing January day in 2010. At the Komsomolsk-on-Amur airfield, among the snow-covered Far Eastern hills, a strange aircraft with the factory designation T-50 taxied onto the runway and lifted off the ground. The first flight lasted only 47 minutes, but those minutes were enough for the whole world to explode. Photos and videos instantly spread across the internet, and the Western reaction was predictably dismissive. Western experts, journalists, and bloggers immediately claimed that the Russians had simply copied the F-22 Raptor, slightly redrawing the fuselage, and that there was nothing new in this machine. Headlines were full of words about a pathetic fake, about how Russia was trying to catch up with America and suffering a shameful failure. But those who understood aviation a bit more deeply than newspaper headlines saw a completely different picture. At first glance, the resemblance to American fifth-generation machines was indeed striking. Slanted edges, tilted vertical stabilizers, characteristic angular shapes designed to reflect radar waves away from the source. Но это не копирование, это физика. The laws of radar are the same for everyone, and any aircraft designed to reduce signature will inevitably have similar features. However, one only had to look closer at the details to realize that Sukhoi designers were following their own path. The main difference between the Su-57 and the F-22 or F-35 is the engine placement. American fighters have engines hidden deep inside the fuselage in a unified construction with the body. Russian engineers acted differently. They placed the engines in separate nacelles, spaced out on the sides, and created a wide tunnel between them. This solution came directly from the Sukhoi Bureau School from the legendary Su-27 line. It was dictated not by laziness or a desire to save money, but by cold calculation. This layout creates additional lift at high angles of attack, and the widely spaced engines with thrust vectoring turn the aircraft into an aerial acrobat capable of performing maneuvers that make the pilot's vision go dark. The vertical stabilizers of the Su-57 are tilted outward, and this is not just a tribute to stealth design fashion. Tilted fins reflect radio waves down and to the sides, preventing them from returning to the enemy radar. But Russian designers went further. They made these fins all moving, turning them into full-fledged control surfaces that work not only for directional control, but also for maneuvering in combat. This solution was directly borrowed not from the F-22, but from its losing competitor, the experimental YF-23 aircraft, which the Northrop Company presented for the Advanced Tactical Fighter competition. The YF-23 was considered faster, stealthier, and more elegant than the prototype of the future Raptor. But the Pentagon did not choose it, preferring maneuverability and proven solutions. Russian engineers carefully studied both American projects and took the best from the losing one. The similarity to the YF-23 was not limited to the stabilizers. The nose of the Su-57, when viewed in profile, surprisingly resembled not so much the YF-23 itself, but its development. A carrier-based fighter concept for the American Navy that was never built. The wide, flat nose, smoothly transitioning into wing blends, created an aerodynamic profile optimized simultaneously for high speeds and for maneuvering at low speeds. The blends in front of the wing, the so-called leading-edge root extensions, deserve separate mention. On the Su-57, they were made movable and worked as a kind of front rudders, almost like the canards on the Su-33 or on European fighters. But at the same time, they did not stick out forward, did not increase radar signature, and did not create extra drag. Together with the all-moving stabilizers and engine thrust vectoring, these blends gave the Su-57 a number of control surfaces that no other fifth-generation fighter in the world possessed. The aircraft could control its position in the air with a precision that pilots of previous generations could not even dream of. But this design also had weak points that critics noticed immediately. The first thing that caught the eye of specialists was the engine air intakes. On the F-22 and F-35, the intakes were designed to completely hide the compressor blades from radar exposure because rotating turbine blades are a powerful radar wave reflector. On the T-50 prototypes, the compressor blades were visible, which caused a storm of mockery. The second problem was the engine nozzles. Round with exposed titanium, they differed drastically from the flat serrated nozzles of the F-22 and looked as if they were taken from a previous generation fighter. Critics triumphed, claiming that the Su-57 was not a fifth-generation aircraft at all, but merely a deep modernization of the Su-27 in a new body. The truth, as often happens, turned out to be significantly more complex and interesting than both sides claimed. From the very moment the first images of the T-50 hit the internet, the main question was not the engine or the armament, but one short word: stealth. How invisible is this aircraft really, and can it even be called a fifth-generation fighter if, according to Western analysts, it lights up on radar like a Christmas tree? To understand this, one must first understand what stealth actually is, because most people imagine it completely incorrectly. Stealth does not mean invisibility. Not a single aircraft in the world, including the American ones, is completely invisible to radar. The essence of the technology is different. The enemy radar detects the target, but it does so too late, at such a distance that an anti-aircraft missile will not have time to reach it, and an enemy fighter will not have time to lock on and fire an air-to-air missile. The B-2 bomber was designed to slip between Soviet air defense coverage zones, and the F-22 was designed to be the first to detect the enemy and strike before the enemy even realizes someone is nearby. This is not magic, it is mathematics. And the key parameter of this mathematics is called radar cross-section, or RCS, a value that shows how large an object looks on a radar screen. And here is where it gets interesting. Patent documents for the Su-57 design, which were leaked into the public domain, indicated a calculated RCS from 0.1 to 1 square meter. For comparison, the radar cross-section of the F-35, according to open estimates, is about 0.005 square meters, and for the F-22, this figure is on the order of 0.001 square meters. The difference is colossal, and critics immediately seized on these numbers, stating that the Russian fighter is closer to the old Su-27 in its visibility than to a real fifth-generation aircraft. But specialists who know how to read more than just headlines noticed a critical nuance. A team of aviation engineers and enthusiasts from the Aircraft 101 project conducted a large-scale independent study. They created detailed three-dimensional models of several modern fighters and ran them through mathematical modeling of radar waves scattering across a wide range of frequencies. The results were extremely revealing. The median RCS of the Su-57 in the 120-degree front sector was 0.48 square meters, which generally matched the data from the leaked patent. The median RCS of the F-35, by the same calculations, was 0.06 square meters. Yes, the difference is significant, but far from as catastrophic as the newspaper headlines claimed. However, the most important thing was hidden in the details. These calculations were performed for the clean shape of the aircraft without considering radar-absorbent materials applied to the surface. According to published scientific works on radar-absorbent coatings, such materials can reduce an object's RCS by a value of 20 to 90%, depending on the exposure frequency and coverage area. Moreover, not a single fighter in the world is covered entirely with these materials. They are applied to critical zones, hatches, panel joints, intake edges, that is, the places where radio waves reflect most intensely. This means that the real RCS of both the Russian and American aircraft in combat conditions is significantly lower than the calculated values for the bare structure. But exactly how much lower, no one outside of secret laboratories can say for sure. Critics who claimed that the Su-57's RCS was 200 or 1,000 times worse than that of the F-35 were simply manipulating numbers, comparing the minimum RCS of the American plane in an ideal aspect with the median RCS of the Russian one across the entire front sector. If one takes a fair comparison in the same conditions, then the Su-57 loses. That is true, but it loses by several times, not by thousands of times. Any modern radar experiences serious difficulties detecting and steadily tracking a target with an RCS of less than 1 square meter, and the Russian fighter fits into this category. The rear hemisphere is a different matter. Those round nozzles with exposed titanium and visible compressor blades, which so outraged Western experts after the first flight, did indeed create problems. Hot metal, rotating blades, and the round shape of the nozzles. All these are powerful radar reflectors, and from the tail side, the Su-57's RCS was significantly higher than that of its American competitors. But Russian designers knew this from the start and did not consider the situation hopeless, because the solution to this problem was built into the project from day one. It was hidden in a new engine that did not yet exist. And it was this engine that became both the main hope and the main curse of the entire program. Russian aircraft designers throughout the Cold War committed the same mistake, and each time it cost them entire programs and billions of rubles. They started building the aircraft before a suitable engine appeared for it. With the Su-57, exactly the same thing happened, only the scale of the problem turned out to be much more serious than anyone could have imagined. When the T-50 took to the air in 2010, it had AL-41 F-1 engines inside, turbines developed based on the well-known AL-31 family, the same one that powered the legendary Su-27. For the prototype's first flight, this was a normal solution because many successful fighters of the world first took to the sky with temporary engines. The French Rafale flew with American motors, and the Su-27 itself began tests with pre-production turbines. No one was bothered by this because replacing the engine with the standard one happened quickly. The problem for the Su-57 was that it did not happen quickly at all. The engine for which everything was started bore the code name Izdaliye-30, and in official documents was designated as AL-51. This motor was supposed to be a true technological breakthrough. Afterburner thrust of over 18 tons, the ability to maintain supersonic cruise flight at a speed of approximately 1.5 Mach without turning on the afterburner chamber. New serrated nozzles like those on the American F-135, and a completely closed hot section that was supposed to solve the radar visibility problem from the rear hemisphere. In essence, Izdaliye-30 was supposed to turn the Su-57 from a very good 4+ generation fighter into a true 5th generation machine. Но его разработка затянулась на годы, and serial Su-57s continued to come off the assembly line with the old AL-41 F-1s. Without Izdaliye-30, the aircraft could not reach supersonic cruise flight in full combat gear. The Su-35, equipped with similar engines, was capable of supercruise only in a light configuration, without external weapons and with a minimum fuel supply, which was practically useless in real combat. This meant that the Su-57, in its current form, was deprived of one of the key advantages of a 5th-generation fighter, the ability to conduct combat at supersonic speed without burning fuel at a monstrous rate on afterburner. On the other hand, in terms of maneuverability, the AL-41 F-1s did their job brilliantly. These engines were equipped with 3-dimensional thrust vectoring. The nozzles could deflect not only up and down like on the F-22, but also to the sides, giving the pilot the ability to instantly turn the machine almost around its own axis. The thrust-to-weight ratio of the Su-57 with a combat load exceeded 1.0, which meant a simple thing. The plane could accelerate while moving vertically upward, and in close combat, this turned it into an extremely dangerous opponent. But modern air warfare has long moved away from close-range dogfights, and all these acrobatic capabilities, for all their spectacular nature, meant little without powerful electronics. And here, the Su-57 showed itself from a completely unexpected side. The N-036 Belka radar complex installed on this fighter had no direct equivalents on any other aircraft in the world. The Belka consisted not of one, but of 5 separate antenna arrays. The main antenna in the nose radome operated in the X-band and provided detection and tracking of targets at long range. 2 side antennas, also operating in the X-band but with a smaller range, were angled out and gave the pilot a nearly 270-degree view around the aircraft. 2 more antennas, located in the wing blends, worked in the L-band at lower frequencies and were used as part of the electronic warfare complex. 5 antennas, working in different frequency bands and directions, created a sphere of awareness around the plane that was extremely difficult to penetrate undetected. In front of the pilot's cockpit was an optical location station, an infrared search and track system that allowed for detecting enemy aircraft by the heat signature of their engines and using infrared-guided missiles without turning on the radar at all. This was the same capability that the F-35 had, but which the F-22 Raptor still lacked. All data from the 5 radar antennas, the optical location station, and onboard sensors were merged into a single picture thanks to a sensor fusion system. The onboard computer processed information streams and gave the pilot a complete tactical situation on the cockpit displays. But the most formidable weapon in the Su-57's arsenal was the R-37M missiles. Air-to-air guided missiles of ultra-long range, capable of hitting targets at a distance of more than 200 kilometers. Hidden in the internal weapon bays, these missiles allowed the Su-57 to strike first, staying far outside the kill zone of enemy fighters. And ahead of the Russian fighter lay another trump card that few people talked about seriously. Its own combat drone, the S-70 Okhotnik heavy strike drone, designed as a loyal wingman to work in tandem with a piloted fighter. The S-70 Okhotnik heavy drone rolled out of the assembly shop of the Novosibirsk aviation plant, looking as if it had arrived from a completely different era. A flying wing without a tail, without vertical stabilizers, with a flat engine nozzle, and a predatory silhouette resembling a smaller copy of the American B-2. Unlike the Su-57, which was designed with maneuverability prioritized over stealth, the Okhotnik was created as a stealth machine from the very beginning. Its shape was dictated by a single task: minimal radar visibility from all angles. And the very problems that plagued the Su-57 with its round nozzles and open blades were solved on the Okhotnik at the drawing stage. The plan was bold and absolutely logical at the same time. The Su-57 was to act as a flying command post, controlling a group of several Okhotniks through a secure data exchange system designated as OZOD, an analog of the NATO Link 16 system. The fighter pilot, staying safe hundreds of kilometers away from the contact line, would detect targets using their radar and infrared sensors and then direct the drones to attack. The Okhotniks, invisible to enemy radars due to their design, would sneak up on the target and strike, while the enemy did not even understand where the threat came from. The size of the S-70 allowed for carrying a serious combat load in internal bays, making it not just a scout, but a full-fledged strike apparatus capable of working against ground and air targets. By the time of the first joint flights of the Okhotnik and the Su-57, it became obvious that this was not a paper project or a general's fantasy. The drone actually flew and actually was controlled from the fighter. But between flight tests and mass production lay a chasm filled with one simple and ruthless word: money. The financial history of the Su-57 was difficult from the start. In 2007, Russia and India signed an intergovernmental agreement on the joint development of a fifth-generation fighter under a program called FGFA. Delhi expected to receive its own two-seat version of the machine and a license for production at Indian plants, and in exchange invested hundreds of millions of dollars into the development program. The main contractors were the Sukhoi company from the Russian side and the Hindustan Aeronautics Corporation from the Indian side. For Russia, this partnership was critically important because Moscow viewed Indian money as the main source of funding for serial production of the Su-57. But the program stumbled time and again. The Izdeliye-30 engine fell behind schedule by years. The latest avionics required endless refinements. The Belka radar went through a prolonged test cycle, and each T-50 prototype cost an astronomical sum. The Indian side watched with growing irritation as deadlines shifted to the right and promises remained promises. Indian military officials stated that the fighter being created did not meet their requirements for stealth, and the combat avionics and radars did not meet the standards of a fifth-generation machine. In 2018, Delhi's patience ran out, and India effectively froze its participation in the program, leaving open the possibility of returning to the project or buying finished aircraft in the future if Russia established serial production. The loss of Indian money was a serious blow to the entire project. Moscow was forced to reconsider its plans. Initial ambitions for 200 machines were reduced to a modest initial batch. However, the situation later improved. On May 15, 2019, the Russian Ministry of Defense announced the purchase of 76 serial Su-57 fighters with delivery until 2028, but production rates remained low. The Su-57's baptism by fire took place in Syria in November 2018. The Ministry of Defense published footage of the aircraft's combat work, reporting more than 10 sorties performed. Even more vague reports spoke of Su-57 participation in aerial clashes over Ukraine. However, in conditions of total information warfare, it is impossible to verify these claims. And now to the question raised in the title of this video. If the Su-57 meets the F-22 in battle, who wins? The honest answer is this. In a pure form, such a duel is extremely unlikely, but the balance of power is not as one-sided as Western experts would like to present. The American fighter excels in stealth, the Russian in maneuverability and missile range. The F-22 has no infrared detection system, and the Su-57 is still waiting for its standard engines. The Raptor has nearly 200 built machines. The Russian fighter has significantly fewer so far. Но именно здесь кроется главная интрига, because the real threat to the West may come not from where it is expected. The Chinese J-20 is already being mass-produced in the hundreds, and its technologies largely echo the developments obtained during the Su-57 program. And while the whole world discusses who is cooler, the Russian or the American, the real chess game is being played on a completely different board. If you like this story and want more such breakdowns, hit like, write in the comments which plane to break down next, and subscribe to the channel so you don't miss new episodes.